Just pointing out from the start of this test, after marking where the horizontal axis is, that this is one of the areas and this is the other area. It's very clear to me that the positive area is smaller than the negative area. So this car traveled forwards a smaller distance than it traveled backwards. I think that's going to influence how I have to set up this lab, especially because question 2 makes it very clear that you need to take that into account when making your position graph. So the only way you could probably acquire this data would be to place the motion sensor on this side of the track. I know this because the cart's slowing down as it travels away from the origin. So I'm clearly pushing the cart up the track because it's slowing down, and it has to have the motion sensor at the bottom of the track to show that the initial displacement is positive. Also though, I can't start the car over here. I'm gonna have to start the car somewhere in the middle of the track, just like it is. That way the car can go a small distance forward and then a larger distance backwards. So in describing what I would have to do, I should probably say something on the order of, I'm going to start with the motion sensor at A, facing up the track. I'm gonna place the car in the middle of the track and give it a small push upwards towards B, and then record the data before the car reaches the motion sensor, or something like that. Everybody understand what I would expect you guys to do on that? A sentence or two. All right. Using the section of the graph provided, please sketch a position versus time graph that represents the motion of the car. All right. So we're talking about this part now. I think an appropriate axis should be drawn in. And yeah, you may not get credit if you're not careful about labeling everything correctly. These are all things I would expect you to do. Now, it's hard to know where to label the vertical axis now, like what meters to put where, and I'd be okay with that, but I'm thinking the car probably starts somewhere in the middle. And we know that at time 0, we have a positive velocity. Some point between half a second and 1 second, the car stops, and we don't know exactly where that is. And then after the 3rd second, it's clearly moving backwards at a pretty fast rate of speed compared to where it started. So I'm probably expecting something that looks like that. So concave down with a place where the slope is 0 somewhere relatively early before the 1 second mark. This just has to be a sketch. Next, what was the rate of change of the velocity for the car over the interval? You got to pick 2 points here in order to find slope. Technically, we're going to be changing a little bit about the way we find slope after this test, but right now I just need a place to kind of pick out that's obvious and easy. So I'm going to choose, let's see, this point and this point seem like best to me. Rise, -6, run is 1. So the acceleration is -6 meters per second over 1 second, or -6 meters per second squared. So that's going to be the acceleration. I'm also going to point out that the initial velocity is +4. Here's where it gets a little bit tough. What was the car's displacement over the first 2 seconds of the car's motion? Well, I don't know how you want to do that. The way I would do that is with a mathematical model of the car's motion. I know how to do that. And knowing that that question is coming up, no reason why I have to do these in the order that I prescribed. Now, you could find where 0 is and do it by doing the areas, and you may have to. But I don't have to. So I'm going to do this. The acceleration is -6, time is 2, initial velocity is 4. This will give me the displacement of the car without having to find out where it crosses the 0. Plus 2 squared. So 2 squared is 4, half of 4 is 2, so that's -12 plus 8. Seems like -4 meters. Any questions about that? Write a mathematical model for the car's velocity. V equals -6t plus 4. Write a mathematical model for the car's displacement. Just did that. Now, you have to plug in 4.5 seconds for both of those. I want to ask, is there anybody who needs me to do the areas? We might have to in a minute, but all right. So I'm kind of in a place where I don't feel like doing 7 or 8. Velocity is going to be -6 times 4.5 plus 4. You guys can handle that, can't you? And delta x is going to equal 1/2 times -6 times 4.5 t squared plus 4 times 4.5. Again, once you've done that, the rest is arithmetic. I suspect you can do your arithmetic correctly. You have all them fancy adding machines. Using either your graph or your mathematical model, when did the car come to rest? I'm going to use my mathematical model. It's hard to do it on the graph and get it right. So v equals -6t plus 4. I'm going to put in 0 for v. This will tell me when the car was at a velocity of 0. So 0 equals -6t plus 4. So t equals 2/3 of a second. What distance did the car travel during the first 2 seconds? Well, I have 2 ways to do that. One of them is to go back and do the areas. That's probably the way you guys did it. You don't have to do it this way. You guys did it, so I'm going to do it that way. 2 seconds, though. That's my boundary. So this is my first interval. I'm going to find the area by doing 1/2. The base is 2/3 and the height is 4. All right, it's 2/3 of a second. So half of 2/3 is 1/3. 1/3 times 4 is 4/3 meters. Car moved that far while coming to rest. My next area here. The base has to go from 2/3 to 2, which is 1 1/3 or 4/3. And the height is -8. Half of 4/3 is 2/3. 2/3 times -8 is -16/3 meters. All right. So I have my 2 displacements now, 4/3 and 16/3. What distance did the car travel in the first 2 meters? Plus 16/3. Looks like 20/3 meters. We good? Yep.
Can you accept like fraction and decimal?
Yeah.
Okay.
I prefer fractions. They tend to reduce easier, but if you did it all in decimals, fine. You're just going to be, the only problem is that this is a non-terminating repeating decimal, so you're going to have a lot of 6s or a lot of whatever. So just make sure that 20/3 is what, 6.7.
6.6.
Well, if you're going to round, 6.7, yeah. But I'm not going to be critical there. All right. Any questions about that? If I'm going to do something like this, where I'm going to have the point where it's at 0, not on a nice perfect integer, there's no reason why I can't. Your mathematical skills should be here. However, this was a makeup test. And by the time the students had done this test, it had been 2 weeks since the original test because of a Labor Day gap in there or something that happened, and so it was 2 weeks later. We had moved on and done other things by then. The makeup test will sometimes incorporate some of the newer skill sets. Does that make sense? So I'm not saying I won't have a test like this. I'm not saying that. I'm just saying that we had moved a little bit away from where we had been at the time that the test was given, and sometimes the makeup test will have to reflect that. All right. We good?
Are there any questions like identifying the mathematical model? You said-
Yes.
Yeah, okay. Just said, like, not identifying the formula, but, okay.
No, you will have to identify the model, and I'm not hiding this. The models have the initial information in them. So this is a model, and this is a model. In fact, truthfully, this model would be better served like that, where I break up the change in, the delta, into its original form. The reason why these are called the models is they can plot the behavior. The other ones can't. Only these can plot the behavior. And that's because these are based on initial information. That's what makes them models. So when we have a question like this where you're asked about a model, the models are the ones that the graphs are based on. So you should be able to get a quadratic and the linear function for the velocity. There's really nothing wrong with asking it on a practice test. So in order to plot the data, though, I have to recognize a couple things about this. My velocity graph has to go from -12 to 9. So I need to choose kind of a range that's going to work here. And I realize that this is at the 1 second mark, but time starts at 0. So there's a couple of things here I might do differently than what you did when you made your graph. So this part is not going to be tested, but I think it's worth talking a little bit about. I'm going to put in some axes here. So this is velocity. This is time. Seconds, meters per second. Graph starts at 0, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8 seconds. The whole idea is to use as much of the graph as possible, but you have to make this a number line, which means you have to have even increments of whatever you're plotting. You've not done that as a class yet. We will be doing a lot of graphing throughout the course of the year. Even increments. Right? And this class, we don't make bar graphs and pie charts. Ours are always going to be data that could be taken in the class and not based on like grouping things together like you might in AP Stat. So our axes are always number lines, which means even increments of everything. And we have no breaks in our graph, which means they start at the origin when possible. Does everybody understand those statements? Because we haven't done any graphing yet, but we will be in our next unit. 9 to 12, I know there's not enough boxes there to go by twos, so 1, 2, 3, 4, 5, 6, 7, 8, oops. I guess I should go by twos. Yeah, I'm gonna leave it like that. So 9 is gonna hang up there. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's -12. First point is 1, -12. Next point is -9 and 2, so 12, 11, 10, -9, and 2. Next point is -3 and 4, so 1, 2, 3, 1, 2, 3, 4. Our next point is 3 and 6, so 1, 2, 3, and that's 1, 2, 3. And then 6 and 7, so. And the last one, 9. I have to draw on a best fit curve. If it's linear, you put a ruler down and do it. If it's not linear, then you draw on the best that you can. This is clearly linear, so put a nice straight line. My y-axis is off the graph, but I'm pretty sure we can figure out where it is. Right, it's got to be -15, just based on the slope. There we go. That's all set. So let's see what the questions have. Create a graph, did that, draw a best fit line, did that. In a complete sentence, describe the motion of the object and where the sensor must have been placed. This object travels with a negative velocity first and then a positive velocity. So it had to be traveling towards the detector while coming to rest and then away from the detector. So I think the detector was placed on the high side of the ramp and the object was placed, since it traveled so much further towards the object, it was placed pretty far away and then traveled towards the detector before stopping, turning around and coming back. Make sense? I think 1 or 2 sentences is probably sufficient. Answer the following questions with data represented in the graph. Find the rate of change of the object's velocity. You will have to learn to do this. And one of the things you'll have to learn to do is that when you take the slope of something based on data, you use the line and not the data points. I wouldn't have expected you guys to do that today, but in the future, that's what I'm going to be having you do. So I'm going to pick places that aren't part of the data set, but are part of my line to find the slope. And using that to figure out what the acceleration is. So that's 1, 2, 3, 4, 5, 6 meters per second in 1, 2, 2 seconds. So my acceleration was 3 meters per second squared. All right. So again, we haven't spent as much time dealing with data yet. We will be. Number 5, create a mathematical model to describe the object's motion for any time. That's too ambiguous, by the way. It doesn't say whether it wants the velocity model or the displacement model. So I'll give both. I will be more specific on the exam. So the velocity model, V equals AT plus negative 15. I got the negative 15 from extrapolating the data, but you could get the negative 15 by taking a data point and plugging it into the formula. So if you'd like to see how that's done, I can do that. Anybody like to see how that's done? Okay. So I knew the slope was 3. So I could say, well, I have a data point here. And that data point is a velocity of 6 at a time of 3 seconds. So using my function without this, because at this point I don't know what that is, I could say, well, let me get this circle out of the way. I could say, well, at time equals 3 seconds, my velocity was 6 meters per second. Oh, I'm sorry, negative 6 meters per second. So what must the initial velocity have been? So I solve this for V naught and get negative 15 meters per second. I just pick a point on the line, plug that in to the function that didn't have initial velocity, and use the slope to figure out where that initial velocity had to be. Could have also done V naught A T delta X and solve for it like that by picking a data point. Maybe picking any of these data points would work. You guys follow along? Is that okay? All right. Either way, it wasn't clear what I was supposed to do here, so you might have also done the other. Did this with negative 15. That'd be just fine. But you also could have done delta x equals 1/2 a t squared minus 15t. And that's a fair model too, and would be just as good. Does the object ever stop? Yes, it stops here at the 1, 2, 3, 4, 5 second mark. What is the total distance traveled by the object in the first 8 seconds? Distance traveled by the object. In the first 8 seconds. Well, I've made a mess of this graph, but this area and that area. Again, you could do something different here. You could use the displacement functions twice and figure it out, but I'm going to do the area because I have a graph in front of me and that seems easiest. So the area here is going to be 1/2, the base is 5, and the height is negative 15. 5 times 15 is 75, half of 75 is 37.5, so negative 37.5. If you did negative 12 from 1 second, our interval starts at 0. The idea that we would start from 0 would probably be something I would want you to consider, not starting at the 1 second mark. I think the year I gave this out, though, I didn't penalize students who started from the 1 second mark. Now let's see, this part, the base is 3 seconds and the height is 9 meters per second. So 3 times 9 is 27, half of 27 is 13.5 meters. So those are my two displacements. I want the distance traveled, I strip off the negative signs and add them together, and that's 51 meters. If the object were to have begun its motion from the origin, where would the object be after 8 seconds? That's displacement. So I can use the information I have to answer that just by adding the two displacements together, leaving the sign intact. That's going to be 0.5's go away. 3 minus 1 is 2. 7 minus 3 is 4. 24 meters, negative 24 meters. If the object were to continue this motion, what would be its speed at t equals 12 seconds? V equals 3 times 12 minus 15. I'm using the model that we developed, plugging in a time of 12. So that's 36 minus 15, positive 21 meters per second. If the object were to continue its motion in the same way, where would the object be after 12 seconds? All right, delta x equals 1/2 a 12 squared minus 15 times 12. I don't feel like doing the arithmetic, so I'll leave the arithmetic to you. That's not unreasonable. There's the sprinter one. That one I think is beneath the level of this class. I think you should expect something more difficult than that. The sprinter goes, I believe the sprinter starts from rest and goes to 8 meters per second in a time of 4 seconds, and then you're asked about the displacement and the acceleration. I am unlikely to make your motion problems this easy. So there's a hint. Your test has harder motion problems than this. I guarantee you every motion problem requires you to consider what you will make positive and what you will make negative. This one does not, because everything's happening in one direction. So I would be more prepared to have a point issued for deciding whether these should be positive or negative. Does that make sense? This all happened in one direction though, so it's not that big a deal. You'll find the acceleration from using v equals at plus v naught. And the acceleration ends up being 2 meters per second squared. And the displacement, you can get that from 1/2 v plus v naught times t. And I believe this is 16 meters. There's not enough here really for the test. Minute and 20 seconds. I'm expecting you to have to do more. So it is likely that your problem will have more to it than that. The second problem, an object was thrown upwards and went 125 meters into the air before coming to rest. You're asked what was the initial velocity of the ball at the bottom when it was hit from the bat. This is closer to what I'm going to expect you to do, but I still suspect this is, at the baseline level for what my expectations are. This is a free fall question. I will expect that you'll know that and say that the acceleration of gravity is 10 meters per second squared downwards. I will expect you to make a decision on positive and negative direction and evaluate each of your vectors to determine whether they should be made positive or negative. I made upwards positive, so I'm making downwards negative. And I can find my answers from just picking motion equations, but it's probably going to be all over the place. It's all of them probably at some point or another. So think this ends up being minus your says what is the velocity, then you're going to be asked to provide the direction for your answer. You were also asked for the time the ball was in the air. So you can use any motion equation now, but I'm going to use one that is fitting for the given information. That's probably the one I would use. 125 divided by 5 is 25. Automatically throw out the negative answer when it comes to time, but this isn't the answer. 10 seconds is the answer. The ball has to come back down. You'll lose a point if you don't recognize that. Yep.
It's
Or I'd say I found, when talking to you about being able to pick out two graphs that are cooperating, that indicate potential position and velocity graphs, that you guys had difficulty. I showed you some multiple choice questions. I'm going to be very direct with you. Probably the hardest part about this test isn't what we've just done, although a lot of you will do terrible. And I don't mean that mean. I mean, every point has to be earned. And you'll note that if you make a mistake early on, many of the parts of the problem are connected. Now, for the most part, I don't penalize you twice for the same mistake. That's the way AP is supposed to grade, which means that, so stuff like that, do these two graphs cooperate? Could these be a position and velocity pair? Because you know that's going to be on the test, right? There'll be a stack of these, and either you'll have to pick out which two graphs could be a velocity and position pair, or I will group them, and you'll have to decide which one you think is a velocity position pair and which one isn't. So my expectation for you guys is to understand whether this pair works or not. I don't think this pair works. The velocity started at rest. That's true for both of them. But this became a more positive number while this was becoming a more negative number. So these would not go together. I could correct it to make them go together. And there's probably two different ways to do that. The way I'd probably prefer to do would be that one. That one works too. Right, starting position doesn't matter. We don't know the starting position, so the only difference between these two is that the starting position has changed. The y-intercept is different, but they are the same parabola. Concave down parabola indicating that the velocity is becoming a more and more negative number. But I also don't want you to be too complacent because these two agree, right? The switch is, this is the velocity and this is the position. The velocity is a constant. So the position graph shows a constant slope. So be prepared for that. Also,